Welcome everyone. In this video lecture, we will solve a diode-based numerical from Microelectronics circuit book. So the question is, for the logic gates of the circuit shown below, this one is the circuit, which is basically a logic circuit. We will discuss which logic gate gate it is, and we have to assume ideal diodes and input voltage levels are 0 volt and plus 5 volt. Find the suitable value of R. Find the suitable value of R such that each of the signal source does not exceed I 0.1 milliampere. So means we have to find the value of basically R where the I value does not exceed. Okay, means I value should be less than this. Okay, so first we have to identify which logic gate it is. For this one here there are three inputs. So for the simplification purpose, I am just making the same circuit with two input. So why I am making with two input, it will be very clear after a few minutes. Okay, so now for example I have just made with a two input. So for example, there are two voltage sources, say VA VB, okay, or say VA VB, and I am saying VY is the input. Okay, so here their possible combination will be 0 0 means logic level 0. Okay, 0 1 1 0 1 1. Okay, means this is the just a combination, okay, of the input. 0 correspond to the logic level 0 volt, and 1 correspond to the high voltage plus 5 volt. Okay, so when these two are 0 means diode will be, if any one of the input is 0, it is 0, because this diode will be on state. Okay, forward bias for a 0 volt. So this will be 0. This one will be again 0 and 0. When both are 1, this would be d1 d2 will be in the off state. So there will be no current in the circuit, and this will just simply by will be high volt. So it will be the logic high. So for 1 1 the output will be simply 1. Okay, so in this case I also just mentioning, when va is 0 means d1 on d2 on. Okay, here d1 on and d2 off. Okay, here d2 off. Okay, here d1 off. Okay, and d2 will be on, d2 on. Okay, here also means both d1 and d2 will be off. So off means it will be open circuited, so there will be no path. Okay, so I current will be 0, so the same potential will be here. Okay, so this one is the simple working. So this one is nothing but simply a AND gate. So this one is nothing but simply a AND gate, two input AND gate, say A and B. So Y will be A into B. Okay, so this one is just basically a AND gate representation. AND gate. Okay, working is very simple. When both are 0, logic level 0 means, once again, further simply, logic level 0 means 0 volt. I am saying logic level 5. Oh, sorry, 1. Better to write here. Logic level 1 means we are giving a 5 volt input here. Okay, so for 0 0, both will be, diode will be on. Okay, d1 on. Okay, d2 on. In this case, once again I am d1 and d2 on, short circuited. Okay, short circuited. Here I had short circuited. Okay, in this case, d1 on, d2 off. Okay. In this case, VA means D1 will be off, but D2 will be on. In this case, D1, D2 both will be off. Okay. So this is nothing but simply a and get. Okay. VY equals to VA into VB we can say, and both are 0, 0, 0, 1, 0, 1, 1, 1. So this one is basically a AND get representation. So now in the question we have to find the value of R. Okay. So when inputs are 0 at low logic level, okay, so the circuit is just it is short circuited. Any one input is 0. So the modified circuit for, say I am saying for as an example, VA is 0 and VB and VC is 1, high level. So the circuit that we will make like this, VA is 0 volt, so I'm just making it ground, and this should be R 5 volt. This should be open circuited for plus 5 volt. Okay. Now once again, it should be like this for the 5 volt. For here, D2, D3 will be open circuited. Okay. So in here, D1 will be in the on state short circuited. Okay. So the equivalent circuit will be very simple, 5 volt, and this one is ground. Okay, means zero potential is there, R is there. So I value. So I value will be 5 minus 0 by simply R. So 5 by R. Okay. In question it is given the I value will be less than equals to 0.1 milliampere. Okay. So from here one can write 5 by 0.1 into 10 to the power minus 3 should be okay. So R should be greater than equals to 50. Okay, means if we remove this decimal it will be 50, then 50 into 10 to the power 3. So R value will be 50 kilo ohm, or R value should be greater than, or like that you can say greater than equals to 50 kilo ohm. Okay, this question is very similar to the last problem. So the thing is that you have to take any condition. VA is 0, VB. One can also take some condition like VA equals to 0, VB equals to 0, and VC equals to 1 volt or 1 logic level high or high level 5 volt. Okay, so these two are on, so grounded, so it should be simply 0 volt again. Then we can, the equivalent circuit will be same. Okay, so then we can easily calculate the value of R. So this is all about this question. So the R value will be greater than equals to 50 kilo ohm. Okay, this one is the right answer. Okay, so this one is from the microelectronics circuit book. So thank you for watching this video.